Welcome to the video lecture on microprocessors. In this video, we are going to discuss about the basic definition of a microprocessor, and then we will observe some of the features of one famous microprocessor that is introduced by the Intel Corporation, that is 8085 microprocessor, and we will see the functional block diagram of 8085 microprocessor, and we will explain the functionality of each block in detail. First, let us see the definition of a microprocessor. What is a microprocessor first? First of all, a microprocessor is an integrated circuit, so shortly known as an IC. You can see the diagram of an IC which is placed on your right hand side. It is known as an integrated circuit. So basically it is a plastic material surrounded by some metal pins, right? So it is an integrated circuit. It contains all the functions of a central processing unit of a computer. So that means this integrated circuit has the capacity to do all the operations that is carried out by a CPU of an computer. And this microprocessor is a programmable, multi-purpose, clock-driven, register-based electronic device. So that means this integrated circuit is a programmable integrated circuit. So which means we can program the integrated circuit, or we can change the functionality of the integrated circuit by changing different programs inside it. And it is a multi-purpose which is used for several applications, and it is a clock driven, means it requires a clock. Basically it is a sequential circuit, and it is a register based. That means internally it has some registers for the storage purpose, and that reads binary instructions from the storage, that is called memory. So whatever the operation you want to do with the microprocessor, you have to tell the microprocessor through a set of instructions. So those instructions are stored in memory, and it accepts binary data and process according to these instructions and provide results at the output. So this is what the basic definition of a microprocessor. In simple, you can say that it is an integrated circuit which has it is an integrated circuit which has all the functionalities of a CPU. And basically it is a programmable, multi-purpose, clock-driven, register-based electronic circuit, and it reads instructions from the memory and process the data given to this microprocessor based on the instruction, and it produces some results. So this is what a basic definition of a microprocessor. And what actually contains internal to this integrated circuit. So the microprocessor contains millions of tiny components like transistors, resistors, and diodes, and all these components are work together to do a particular operation. So the IC, the microprocessor, is an integrated circuit which is a combination of several components like transistors, resistors, and diodes. So these are all the internals of an microprocessor. So basically we can say that it is a simple IC, but the important thing is it is a programmable IC. Now let us see some of the specifications of this Intel 8085 microprocessor. So basically it is an 8-bit processor which is implemented by using NMOS transistors, and it is introduced in the year 1977 by Intel Corporation. So basically it is an 8-bit processor. That means whatever the operations that is carried out by this microprocessor, it performs all those operations on 8-bit data only. And it is a NMOS microprocessor. That means all the functional units and all the circuitries are implemented by using N-type MOSFETs only. And it is a 40-pin IC. It comes with 40 pins. As you already see in the previous diagram, there are 40 pins which are surrounded on both sides of the integrated circuit. And the Intel 8085 uses 5 volts power supply. It uses plus 5 volts DC power supply to operate, and it runs with 3 megahertz clock cycle. It uses 3 megahertz of clock frequency, and each clock cycle time period is 320 nanoseconds. So internal to this microprocessor, it has an 8-bit data bus. The data bus is 8-bit wide. That means it carries 8-bit of information from one functional unit to another functional unit. And it has 16-bit address bus. So with the 16-bit address bus, it can address up to 2 power 16 kilobyte. That is 2 power 16 is nothing but 64 kilobytes of memory it can address. So it has two 16-bit registers. One is a stack pointer, another one is a program counter, and it has six 8-bit registers as well. So as we already said, it is a register based. That means internal it has six 8-bit registers. So those 8-bit registers are B, C, D, E, and HL. So these are the 8 registers. So sometimes these 8-bit registers can be paired, and it can be used as a 16-bit register, and only the pairing combination it allows is BC, DE, and HL. The next thing is where this microprocessor is used. So the Intel 8085 is used in mobile phones, microwave ovens, and washing machines, and etc. Some of the examples of these devices. Internal to these devices, it contains an 8085 microprocessor. So this is the functional block diagram of an 8085 microprocessor. You see there are a lot of functional units, some of the registers. So all this functional block diagram can be categorized into 5 different blocks. So the first block is known as an processing unit. You can see I am marking the processing unit. So this is called the processing unit. So the processing unit is composed of accumulator, temporary register, and a flag register, and an ALU. We will see the functionalities of each block. So there is a one portion that is called processing unit, and this is the second. You can see I'm marking out. So this is the second portion. So this is called storage and interfacing unit. Storage and interfacing unit. And next there is a third block. So this is my third block. So this is called instruction unit. So these are the three main functional blocks, or three. You can categorize the entire 8085 architecture into these three functional units. So one is the processing unit. It consists of four blocks. Another one is an instruction register. It consists of 3 blocks. Another one is a storage and interfacing unit. It consists of some of the registers and some buffers. So we will discuss each unit one by one. The first one is an accumulator. As we already see, the accumulator is a part of processing unit. So basically the accumulator is an 8-bit register. It is an 8-bit register, and it has a very important feature, that is that this 8-bit register is used as one of the operand for most of the arithmetic and logical operations. So it is used to perform arithmetic, logical, and some IO load and store operations as well. And it is internally connected to the ALU, because one of the operand is always placed in the register accumulator, and after performing any operation or executing any instruction, and the result of that operation and the result of that instruction is again placed back into the content into the accumulator register. So that's the use of the accumulator. And another functional unit is called arithmetic and logic unit, shortly known as an ALU. So as the name itself indicates, it performs several types of arithmetic and logical operations like addition, subtraction. These are the arithmetic operations, and like some of the logical operations like AND or exclusive or NAND. So these are all some examples of logical operations, and all these operations are carried out on 8-bit data only, because as we already said in the specifications, this 8085 is an 8-bit microprocessor. So that means whatever the operations it is carried out, so that can be carried out on 8-bit data only. And we have some general purpose registers which are the part of the storage and interfacing unit. So there are 6 general purpose registers that are available in the 8085 microprocessor. So these registers are called general purpose because these are accessible by the programmer. So these 6 general purpose registers have a specific names. Those are B, C, D, E, H and L. So these are the 6 general purpose registers. Each one is 8-bit wide. So in some situations, in some cases, if we wish to store a 16-bit data, so two of these 8-bit registers can be paired and can be used as a 16-bit registers. And the pairing possibilities it allows is BC, DE and HL. So that means whenever you want to store a 16-bit data, either you can use the registers B and E as a pair, or register B and C as a pair, or register D and E as a pair, or H and L as a pair, right? So only these are the 3 pairing possibilities. You cannot use B and D together, or you cannot use C and E together. Only the pairing possibilities it uses is BC, DE and HL. So these are some of the general purpose registers that are available in 8085 microprocessor. And the next is a program counter, shortly known as a PC. It is a 16-bit register. Previously we seen 6 general purpose registers, and this PC is a special purpose register. That too, it is a 16-bit wide. And this program counter, shortly known as a PC, it always used it is used to indicate the memory address of the next instruction to be executed. So it always points what next to be executed. So for example, if you are executing a 10th instruction, the program counter indicates after execution of this 10th instruction, what is the next instruction to be executed. So it is always points the address or the memory address of the next instruction to be executed. So that's the use of the PC. So another 16-bit special purpose register is a stack pointer, which is known as an SP. So this is a pointer. It always holds, or this stack pointer holds the address of top of the stack. So basically a stack is nothing but a temporary storage, a temporary memory storage, which is a part of the RAM. And it also has a temporary register, which is also an 8-bit temporary register. So as the name itself indicates, it is a temporary register, means which holds some temporary data while executing some of the arithmetic or logical operations. So while executing some of the arithmetic and logical operations, the temporarily generated data is being stored in this temporary 8-bit register. Next is a flag register. So sometimes it is known as a PSW, program status word. It is also called as a PSWR, program status word register, or shortly known as a flag register. So this flag register is also an 8-bit register. So we all know that how the registers are formed. The registers are formed with the help of flip-flops. So out of these 8-bit register or 8 flip-flops, only 5 of them are used. So actually this flag register indicates the status of the result. So after executing a particular instruction, we have some result, and the result type or the status of the result is indicated by this flag register, which is indicated by the internal flip-flops. Right. So out of these 8 bits, only 5 bits are used. So this is the format. You can see there are D0 to D7 total 8 bits in the register. So out of these 8 bits, only D0, D2, D4, D6 and D7 are the used, whereas D5, D3 and D1. So these are the 3 bits. These 3 bits are not used, only 5 bits are used. And these 5 bits are, one is the sign bit, 0. So you can say sign bit or a sign flag. So one is a sign flag, 0 flag, auxiliary carry flag, parity flag and carry flag. Right. So if my result is a negative result after executing any instruction or any operation, if my result is negative, then my sign flag or sign bit is set to 1. So that means my sign bit, or whatever the D7 is my sign bit. So if this D7 stores a 1, meaning is that my result is negative. So similarly my D6 is a 0 bit. If my result is 0, it is set to 1. If my result is non-zero, it is set to 0. Similarly my D4 is known as an auxiliary carry, so which is set or reset when you are performing operations on BCD data. If there is a carry generated from 4th bit to the 5th bit, this bit is set to 1 or else this bit is set to 0. And my second bit is a parity flag, right? So this parity flag is set to 1 when my result contains even number of ones. If my result consists of even number of ones, then this bit is set to 1. For odd number of ones, this bit is set to 0. And there is a D0 bit, that is a carry flag. So this carry flag is set to 1 whenever there is a carry generated while doing any addition operation, or whenever there is a borrow is taking place when there is a subtraction operation. So this is used to indicate that there is a carry or there is a borrow after completion of addition or a subtraction. So likewise, out of these 8 bits in the flag register, 5 bits are used to indicate various positions or various status of the result. So next unit is a timing and control unit, which is a part of the instruction unit. So the important of this timing and control unit is, as the name suggests, it generates the necessary control and signals, timing information. It generates the necessary control signals to execute a particular instructions. So it provides timing and control signals to the microprocessor to perform operations. So the following signals, some of this control and status signals, it is generated by this unit is, it generates the control signals like ready, read, write and ALE. So the ready signal is indicated that whether the IO device connected to the microprocessor is ready or not. If that IO device generates a ready signal, then the microprocessor performs some operations on that. And also it generates some of the status signals like S0, S1 and IO by M bar. So these indicates whether it is performing IO operation or a memory operation. And it also generates some of the DMA, direct memory access signals, that is hold and HLDA, that is hold acknowledgement. It also generates some of the reset signals. One is a reset in, another one is a reset out. So the reset in signal is used to reset the microprocessor, that is the microprocessor, and the reset out signal is used to reset the devices which are connected to the microprocessor. So that's the use of the reset in, reset out. And the next functional unit in this architecture is an interrupt control, right? So as the name suggests, the interrupts are generated by the IO devices during an execution of an instruction. So while the microprocessor executing one program, so if an IO device is required to execute another program, so that IO device can interrupt the normal execution of the microprocessor by generating one signal called interrupt. So the interrupts, whatever the interrupts that are generated by the IO devices, that are controlled and handled by this interrupt control unit. So basically this interrupt control unit accepts five different type of interrupts. These interrupts are also called as a hardware interrupts. So the names of these five different interrupts are, one is the INTR, that is interrupt request, and RST 7.5, RST 6.5, RST 5.5, and trap. So these are the five different type of interrupts, and each interrupt having a particular priority level. So when two or more interrupts are at a time accessed, or when two interrupts are generated at a time by IO devices, so the microprocessor will give the highest priority, or the microprocessor will serve a particular interrupt which is having highest priority. So out of these five interrupts, trap having the highest priority and INTR having the least priority. The next unit is a serial input output unit. So this, there are two inputs, SID and SOD, serial input data and serial output data. By this unit, the microprocessor can transfer the data serially. Another unit is a address bus or a data bus buffer. So this is a buffer unit. Through this unit only, whatever the IO devices or memory units, the external devices are interfaced to the microprocessor through these devices only. And there is an address and data bus. So as we already defined in the specifications, it has 8-bit data bus and 16-bit address bus. So this 8-bit data bus is also known as a multiplexed address and data bus. So that means these 8 lines will carries address and these 8 lines will carries data. So that is separated with the help of timing. So that's why it is known as time multiplexed address and data bus. So basically the address bus is used to carry the address, whereas the data bus is used to carry the data. So that's all for today. Thank you.